Hello, my name's Darren Holmes, and today in Getting Started with MicroPython book, we're going to explore Chapter 7, Building a Burglar Alarm. So we're going to be using the HC-SR501 PIR sensor. Keep in mind, our Raspberry Pi Pico works on 3.3 volts, so our sensor also has to output a 3.3 volt signal. It says here, a passive infrared sensor is designed to detect movement, in particular movement from people and other living things. So it works a little bit like a camera, but instead of capturing visible light, it looks for heat emitted from a living body. So I just want you to note it's known as a passive infrared sensor rather than an active infrared sensor, and that's because it doesn't send out any infrared signals of its own. It just detects signals. Now the actual sensor is buried underneath a plastic lens, typically shaped like a half football. The lens itself is not technically necessary for the sensor to work, but it provides a wider field of vision, FOV. So without the lens, the PIR sensor would only be able to detect and see movement in a very narrow range in front of the sensor. So the lens serves to pull in infrared from a much wider angle. So before we wire up our PIR sensor to our Raspberry Pi Pico, we need to go out on the internet and find out what the pins are. We also need to know the function of those two potentiometers and what the jumper settings should be. So I'm going to do a little search in Google and see what I can find on this particular sensor. So going to Robot Shop, you can see that this is your PIR sensor. It's end of February 2022 that I'm making this video, so the current price in Canada is $3.27. So scrolling down, you can see under specifications it says working voltage DC 3.6 to 30 volts. But it doesn't seem to say too much else about it. So what I've done is I've gone to Google and done a search on the HC-SR501, and one of the websites that came up was Last Minute Engineers. So they've got a section here on how the PIR motion sensor works. So you can see inside we have this tiny sensor. Then we have our lens on the outside, giving us a detection area. And basically it's going to notice when a heat source moves. So it's infrared. Infrared is heat. So here we have a little graphic of the output of our sensor when motion is detected. And eventually we find this little board layout. So this is kind of the thing that we're looking for. You can see we have a ground and a VCC, and the center is our digital out. We have a protection diode, and we have a 3 volt DC regulator. So when we have a regulator and we have a protection diode, the regulator is going to produce 3 volts output. The protection diode is going to need about 0.7 volts. And we need about 1 volt above the voltage regulator for it to work. So that's why VCC needs to be 5 volts. Our digital output is going to be based on the voltage of the voltage regulator. In this case it's a 3 volt voltage regulator, so our maximum output should be about 3 volts. And you'll notice we have a signal processor. Because this is not a digital signal, we need a signal processor on the board. So it says here there are 2 potentiometers on the board to adjust a couple of parameters. So this one is for sensitivity, and this sets the maximum distance that a motion can be detected. It ranges from 3 meters to approximately 7 meters. The second potentiometer is for time. This sets how long that the output will remain high after detection. At a minimum it is 3 seconds. At a maximum it is 300 seconds or 5 minutes. So it says finally the board has a jumper, and it has two settings. H, this is the hold repeat triggering. So it will continue to output a high signal as long as it continues to detect movement. So this is your PIR sensor, and this is when it detects movement. It has to have the high and the low. So our jumper setting is high. So when it detects a high and a low, our output goes high. So in the second example here, our jumper setting is still high, but the PIR sensor is continually sensing motion. So you can see it has a couple of cycles. So our output remains high while the motion is being detected. In the second jumper setting, where it's L, this is the intermittent or no repeat non-retriggering. So when you take a look at our jumper setting, you can see the voltage is low all the time. So as above, when the PIR sensor detects motion, once it's done one cycle, it outputs a high. But it does not do anything with the second set of motion, so the second set of motion does not extend our output. So it says here, making the PIR sensor more versatile. There's a couple sets of pads on here, one labeled RL and one labeled RT. So RT is meant for a thermistor or temperature sensitive resistor. It says adding this allows the HC-SR501 to be used in extreme temperatures. It also increases the accuracy of the detector to some degree. The second set of pads are for RL. This connection is for the light-dependent resistor, or LDR, or photoresistor. By adding this component, the HC-SR501 will only operate in darkness. So this is a common application for motion-sensitive lighting systems. And then finally we have the PIR sensor pinout. So we can see it's VCC, output, and ground. So they've got a little section here on using the PIR sensor as a standalone unit. So you can see they've hooked it up to a set of batteries. So the batteries are providing power to our sensor. We have the common providing the ground to our sensor, and they're using a 220 ohm resistor going through an LED to ground. So when this detects motion, the LED will go on. And then lastly, they say things to consider before designing PIR-based applications. So you note here it says that most PIR sensors require some time to acclimatize to the infrared energy in the room. So on startup, this is going to take 30 to 60 seconds. It says, in addition, the sensor has a reset period of about 5 or 6 seconds after making a reading. So during this time, it will not detect any motion. So you can see here it says the signal processing IC is a BIS0001. So let's try and find a little more information about this. And you can see here it's a micro power PIR motion detector IC. So I've managed to find a pinout for it. We have a pin description. We have a couple of calculations that we can do, and we have to reference the schematic for the parts and their values. We have absolute max ratings, so our supply voltage can be anywhere between 3 and 5 volts, and we know that we're going to be using an onboard 3-volt regulator. We should note that the output current has a maximum of 10 milliamps. So if you're trying to drive more than an LED or another IC, you're going to have problems with this. So as shown previously, this is the retriggerable waveform. So you can see where we get multiple detections, it will extend the output. And we have the non-retriggerable waveform, where it detects multiple motions but only has a single output that is not extended. So this is non-retriggerable. So we have an internal block diagram illustrating how the device works. As you can see, there are several comparators. Then they give us an application example. So this particular example uses 12 volts and a 5-volt regulator. This is the output pin that goes to a transistor, and the transistor turns on a 12-volt relay. So our 3-volt output goes through a 2.2 k ohm resistor to the base of a transistor. The transistor is used to turn on the current, which comes from a 12-volt source through the relay to ground. So the output is turning on ground for the relay. You'll notice off of pin 9 we have some kind of sensor. So this is labeled R3, and the arrows coming in mean it's a light sensor. This is our infrared sensor sitting over here on the left-hand side. So I went out on the internet, and at this particular website I found another schematic, and you'll notice it's using a PIR. So this is the PIR sensor. This is the BISS0001 signal processor. You can see it shows the jumper for whether it's retriggerable or non-retriggerable. We have our ground pin, our output pin, and our input voltage. You can see our input voltage is going through this protection diode that's dropping about 0.7 volts. And it's going through, I believe this is a 3.3 volt voltage regulator. So that's powering the IC. Pin 9 is going through a 1 megohm resistor and then a CDS. So I wanted to find out a little bit more about a CDS. So I went back to the robot shop and I found a mini photo cell light sensor. And you can see when it has light, it has a resistance of 1 k ohm, and when it's dark, it has a resistance of 10 k ohms. So I think this is something that I would like to add in a future video. So let's take a look at wiring up your passive infrared sensor. You can see we have a black lead, which is going to be our common, and they've got it going to pin 3 on our Pico. The red lead is going to pin 40 on our Pico, and they're using a blue wire going to pin 34. So let's go back and take a look at the appendix. So looking at the appendix, we can see that pin 3 is indeed connected to ground. Pin 40 is connected to V-bus, and pin 34 is connected to GPIO 28. So looking back at our Raspberry Pi Pico schematic, we can see that V-bus comes directly off of our USB connector. So V-bus is before it goes through the voltage regulator and comes out at 3.3 volts. So V-bus is going to be 5 volts. This is the lens. So the lens is actually plastic. You can actually take this off. So if you just pry on it gently, you should be able to get it to snap off. And when you snap it off, you can see this is the little sensor. And on here they have labeled those pins. So those pins you connect it up to, you can see on the right hand side, that's VCC. The center is output, and over here on the left is ground. So the plastic lens just has 4 little posts that just snap onto the board. So just remember, it's VCC, output, ground. So if you have a set of these male to female connectors, it's fairly easy to hook up. All we do is put the red lead to VCC, the white lead to data, and the black lead to ground. So then to hook these wires up to your Pico, what the book says is they're going to use ground on pin 3. And then they need 5 volts, and 5 volts is only available off of pin 40. Then finally the white lead is going to go to GPIO28, which is pin 34. So it might be a little more tricky to find pin 34. So the next pin is 35, and then after that is 34, which is GPIO pin 28. So what to do if you do not have those male-female connecting wires? You can see that the connector on here will not fit into your breadboard. So what you can do is you can solder some wires on, or you can take your needle nose and you can actually come in and bend each pin individually. Now don't try and bend all 3 pins at once. So just bend them on a right angle, one at a time. And then once you've started the bend, then you can come back here and continue and get them at the right angle. So once you've got them bent at the right angle, they should be able to fit into your breadboard. With your passive infrared sensor firmly mounted to your breadboard, you want the dome pointing away from your body heat because you don't want this triggering all the time. So the red lead that goes to pin 40 of the Pico brings in the 5 volts. The white lead, which is the output from your PIR, goes to GPIO 28, which is pin number 34 on your Pico. And the black lead, which is the common or the ground, I've just taken it off and run it up into the ground bus on my breadboard. Okay, before we program our Pico, what we're going to do is we're going to test or set up our PIR. We need to do this before you try using it because we won't know, is it the code on your Pico that doesn't work, or is it the PIR that's not working? So I'm going to show you how to test it now. So before you put code into your Pico and then wonder why it doesn't work, make sure that you do set up your PIR sensor correctly. So you can see I have the red line going to the power pin, black line going to ground or common. The white line is my output from my sensor, and I have it hooked up to a 330 ohm resistor going to the long leg of my LED. The short leg of the LED is going to ground. Make sure that you have the jumper in the L position, which means towards the top of the board as shown here. The 2 potentiometers, the one in the center is for sensitivity, so you want the numbers on the top of the tab. The next one over is for the amount of time that the LED stays on. So you want that for a short period of time, so you want the numbers on the little tab pointing towards the right hand side of your PIR. If you have the jumper set in the wrong position and you have the time set up for the maximum, which I think is about 5 minutes, the LED will just stay on all the time when it's triggered. And this will cause a problem for your program because it's edge triggered. So keeping it on for an extended period of time would be a problem for your program. So as you bring your hand in, you should see the LED turn on. So to program the Pico for the alarm, we're just going to import machine, import U-time, and then for our sensor, we're just going to call it sensor underscore PIR. It's a little more descriptive. You can see it's going to be machine pin 28, machine pin in, so that's a digital input, and we're going to be using the pull down resistor on it. Now it says, like the reaction game we just made, the burglar alarm's input should act as an interrupt. So what we're going to do is define a interrupt service routine, so we're going to call it PIR handler. and it's going to send us the pin. We already know it's going to be 28. First thing we're going to do is go to sleep for 100 milliseconds. And then we're going to say if the pin value, and then we're going to print alarm motion detected. Okay, so we probably haven't seen if pin dot value. Normally we'd see something like if something is equal to something. But in this case, the pin is a digital input, so it's going to be a 0 or 1. So we can get away with saying if pin value. Really we're saying if the pin value is equal to 1, we're going to print the alarm motion detected. Then in our code we have to set up the interrupt. So we do that by saying sensor PIR.IRQ, which is interrupt request. The trigger is going to be equal to machine pin.IRQ rising. So that's when it goes from a logic 0 to a logic 1. And our handler is PIR handler that we defined earlier. So this is my code that I've typed into Thonny. You can see I've called it burglar_alarm.py. I'm importing the machine, importing UTime, setting up my sensor pin. So that's on GPIO 28. I've defined my interrupt service routine, and then I've activated my interrupt. So I'm going to go ahead and run this for you. So you can see it's sitting down here waiting for something to happen. I'm going to run my hand in front of the sensor, and you can see it says alarm motion detected. So in the next section of the book we're going to add an LED to our burglar alarm. Now in our interrupt service routine we're going to want our LED to blink a few times. In this case we're going to have it blink 50 times. So because we know the number of times we want it to blink, we're going to use the for statement. And we're going to use LED toggle. And we're going to wait 100 milliseconds between the LED toggling on and off. So in the book there's a talking point about value versus toggle. And you can see there are times when using the toggle function over setting a value makes sense, like when blinking an LED. So we don't need to really know if the LED was on or was off. We can just toggle it and it will change to the opposite state. So you can see this is going to be your finished code. So I'll show you what that looks like in Thonny. So I've typed the finished code into Thonny. I've added a few extra spaces so that my equals line up. And you can see in our interrupt service routine, we're going to print alarm motion detected, and then we're going to toggle the LED on and off 50 times. So you're not going to be able to retrigger your alarm until it's done toggling the LED on and off 50 times. So that's 50 times 100 milliseconds. So I'm going to run this and show you what it looks like. So you can see coming off of pin number 20, which is GPIO 15, I have my 330 ohm resistor. It goes to the long leg of my LED. The short leg of my LED is connected to the ground bus. So when I trigger this, you'll notice that the LED flashes 50 times and is in the off position. So because we had the LED blink an even number of times, if it started off, then it ended off. But if it had started on, it would have ended on. So just to prove that to you, I'm going to run this 51 times. So once again, starting with the LED in the off position, I'm going to activate my alarm. It's now going to blink 51 times. So one of the things we can do is in our handler, where we're blinking this thing 51 times, when we come out of the for loop, we can say LED.off. So this will make sure the LED is off regardless of the number of times we toggle our LED. Notice I'm making use of the comment, little hash symbol, so that I can put in a comment here that says make sure the LED is off after toggling. So I'll show you what that looks like. So once again, starting with the LED in the off position, I'm going to trigger my alarm. And the LED is going to blink 51 times. And in this case, it ends with the LED being off. In the next section of the book, it says to make your burglar alarm even more of a deterrent, you can make it flash slowly, even when there's no motion being detected. So this lets intruders know that the room is being monitored. So all we have to do is add the following 3 lines of code to the bottom of our program. So at the bottom of my code, you can see I have while true, LED toggle, U times sleep. The book has 5. I'm going to put it at 3. It looks a little bit better in the video. There might be a question coming up, and that question is, okay, if we're down here doing this in an infinite loop, what's going to happen when our PIR sensor is tripped? Well, remember up here, we've got sensor underscore PIR dot IRQ. So when the sensor detects movement, it's going to send an interrupt to our Pico. So if we're down here toggling and our Pico gets the interrupt, it's automatically going to go up here to the handler. It's going to do what the handler tells it to do, and then it's going to come back to our infinite loop and continue on where it left off. So here, I'll show you what that looks like. So right now, it's running that slow blinking light. It's off for 3 seconds and then on for 3 seconds. Now I'm going to trip the sensor, and you notice it starts blinking rapidly. That's 51 times I have it set up for. And that goes back to the slow blink, 3 seconds on, 3 seconds off. So the next section of the book is inputs and outputs, putting it all together. So now what we're going to do is add our little piezo buzzer to our circuit. So the black wire goes to ground, and the red wire is going to go to pin number 19. So remember, previously pin number 19 was GPIO output number 14, and we have to tell it that it's an output. Also in our interrupt service routine, we have to turn the buzzer on and off so that it kind of beeps for us. So we have to do a buzzer.toggle. So the book gives us the finished code. You can see we're going to put the PIR sensor on pin 28, the LEDs on 15, and the buzzer is on 14. Next thing we do is set up our interrupt service routine that we call PIR handler. So as soon as our passive infrared sensor goes off, it comes and does this handler. So we're going to have a sleep for 100 milliseconds, and then if the pin value is equal to 1, this is a shortcut for saying pin value equal 1, we can print the alarm, motion detected, and then we're going to toggle our LED, toggle our buzzer, so it makes a beeping sound, and then we're going to sleep for 100 milliseconds, which is equal to 0.1 seconds. Next thing we have to do is tell it that we're going to do an interrupt request on machine pin IRQ rising. In the meantime, while everything is true, we're going to toggle the LED on and off slowly. Okay, so it's hard for me to show you the entire chunk of code in Thonny, but you can see it's pretty much what was in the book. Keep in mind, I've added some extra spacing here to line up my equal signs, and I've been toggling it 51 times. So I'm going to show you what that looks like running right now. So sometimes it's hard to get everything in the picture here, but you can see the red line for my buzzer is actually going to go right beside the resistor for the LED. So that's in pin 19. And then the ground for the buzzer, I actually have it hooked up to the ground that's going to the LED, just as a shortcut for hooking it up. You notice my LED is blinking slowly at about 3 seconds on, 3 seconds off. So I'm going to activate my alarm, and you'll see it's beeping 51 times, and because it was an odd number, it leaves the buzzer running. So if you have an odd number of toggles, to make sure that the buzzer is in the off position when you're done with it, you have to add a little line of code that says buzzer.off, and I've put a comment there. just so that I know when I come back and look at it why I turned the buzzer off. So I'm going to run this code and show it to you again. And this time it stops with the buzzer in the off position. So you can see the book has another talking point. This time it's a warning. It says when using an active buzzer, which is the type we're using, it says it will continue to sound for as long as the pin it's connected to is high. So in our case, we had an odd number, and when it finished the odd number, it was left in the high position. Now it also says in here pressing the stop button won't turn it off, because even though you've stopped your code from running, that pin is still high, so you have to unconnect your USB cable to shut the buzzer off. So then in the code I showed you how to end the code with buzzer off, and that will stop the buzzer from continuing when you're done using it. So the next section of the book talks about extending your alarm. So what they're going to do is add a second PIR. Now what pin is it connected to? Well, this is pin 1, this is pin 20, this is 21, 22, 23, 24, 25, 26, 27, 28, 29. So the second PIR is going to be connected to pin 29. And looking it up in the appendix at the back of the book, we can see pin 29 is GPIO22. So we're going to need to add a couple new lines of code. The first one is to set up sensor PIR2. And as I said, that's going to be on GPIO pin 22. We also have to set up a second interrupt request, and we're going to send it to the same handler. So then we're going to have to modify our interrupt service routine. So in this case, we're going to put in an if statement, and the if statement's going to be if pin is sensor underscore PIR, and we're going to say print alarm motion detected in bedroom. Else, if pin is sensor PIR2, we're going to print alarm motion detected in living room. And then we're going to come in here, and for 50 times we're going to toggle our LED, toggle our buzzer, and put a short break of 100 milliseconds between those toggles. So I've had to reduce the size of the book on my screen so that I can show you the completed code. So you can see I have the code loaded into Thonny. I have sensor PIR on GPIO28 and PIR2 on GPIO22. The LED is on 15 and the buzzer is on 14. Then I have my interrupt service routine. I'm just going to leave it at an even number of toggles so that I don't have to turn the buzzer or the LED off when I'm finished with it. It will be off if it started in the off position. You'll notice I have two IRQs, one for the first PIR, one for the second. And my LED is just going to toggle on and off slowly. I'm going to put it at 3 seconds. It just works easier for the video. So I'm going to go ahead and run this with my second PIR in my living room. So I didn't have a second PIR when I was doing the video. So what I did was I just moved it down from where I'd put in the first one. So this second one is going to be for my living room. So what I've done is I've got the ground pin going to the ground bus, and I have the power pin going to the power pin of my first PIR. So the first PIR is the one that's going to the bedroom. Now you can see I have the white wire, which is the signal coming from my first PIR, and then I've used this blue wire for the signal coming from my second PIR. So I'm going to set the alarm off, and it says alarm motion detected in living room. And if I move my PIR back to where the first PIR was located, and I activate it, So now when I set the alarm off, you can see it says motion detected in bedroom. So this concludes the video for chapter number 7. As you can see, you can have a lot of fun with your Raspberry Pi Picos. In the next chapter, chapter 8, we're going to be building a temperature gauge. It's all about analog to digital conversion. So please don't forget to subscribe, turn on your notifications, and I hope to see you on the next video.